For the study module, is that, I didn't look into it too deeply, that's
Yeah.
just like the next assignment then?
Yeah, so it's not due for a whole nother week. So it's like next Sunday night is when it's due. But that's the one you want to start working on and just do what you can as we go along.
Okay.
So if you come across the question and you're like, we haven't talked about significant figures yet, because we haven't, just say, I don't know, and then like skip through until you find one that you're like, oh yeah, we talked about this topic, and go ahead and do it. Does that make sense? Okay. I know it's a little bit weird because you guys are used to like probably an assignment that you like complete and turn in the next day, and that is very different than what we're doing. So okay. Maybe. There we go. Okay. All right, so we'll go ahead and get started. I'm going to hand around the roll, but I'm going to wait like 10 minutes to make sure everyone's here. Maybe not in this class, but no joke, there are still people that are going to the wrong class and thinking they're in the right place. So if I printed this out this morning so that we have a fresh copy, if you're not listed on here, that means you're not registered in this class and you're not going to get a grade and you're not going to get credit. You're not paying for it, all of these things. So if you're not listed here, you need to come talk to me, okay? And if you are, great. Just check off by your name so that I know you're actually showing up. So you're not stuck in some other room that you should be here. Okay? This is more for the 11 o'clock class because there's 2 11 o'clock Chem 1s. That is confusing people, but hopefully most of you are here and should be here. All right, so in last class, we kind of talked about definition-y stuff, I would say. So we looked at how to categorize matter. You've got atoms, little building blocks. They bond. That word means a very specific thing. It's a very strong force that's holding them together. So they bond and form molecules. If those molecules have 2 different types of atoms, now you're talking about a compound. And all of those things are pure substances. So when we say water, if we said pure water, we mean that all of the stuff in there is just oxygen with 2 hydrogens bonded to it and lots and lots and lots of those little molecules, okay? When we start mixing 2 pure substances together, that means there's a mixture. If they don't interact in any way, so none of the mixtures have bonds between the 2 pure substances, but if they don't interact in any way, that would be a heterogeneous mixture. So like another good example would be oil and water. So think salad dressing. You can shake it up, but it's immediately going to separate back out. So they're 2 pure substances. If you just did this with like straight oil and straight water, you'd have 2 pure substances, but the molecules don't want to interact with each other in any way, and so they won't form a uniform mixture. So that would be heterogeneous. Homogeneous is where there is an interaction. So you put sugar or salt in water and shake it up, it's going to look uniform, and the reason why is because there are interactions happening between those particles now, okay? Not bonds, but an interaction that holds them uniform throughout the mixture, okay? So we talked about that. We talked about energy and how we describe that in chemistry. So just kind of reiterating so that everyone hears it, it's always good to hear things lots and lots of times. The key point in all of chemistry is going to be about how positives and negatives interact. So when we look at a single atom, all of the protons are in the nucleus, meaning they're smushed together, okay? So when we say that there are 3 protons in this atom, this is lithium, it says +3, meaning there's 3 protons. They're all acting as one thing. It's not like the 3 protons act individually as a +1, a +1, a +1. It's one thing that has a +3 charge. You can think of it kind of like strength. It's 3 times strong, whereas carbon is 6 times strong, okay? So the electrons are different because they're spread outside of the nucleus, and there are 3 in a neutral lithium atom, as well as 3 protons. There's 3 electrons, but they are spread away from each other, and so they do behave independent of each other. So this electron is going to have a particular attraction to the nucleus, and this electron is going to have its own attraction to the nucleus. Okay, so all those dotted lines are to show you those attractive forces. Put one on this one as well. Okay, and the thing we didn't really talk about, and we're going to get into this more and more over the year, is repulsive forces. So there's also repulsive forces between things that are like charged. So the negative electrons actually push away from each other. And what's dictating how things are going to move around, how electrons are going to move in an atom, how different atoms are going to interact with each other, is this desire or this tendency to go towards a lower potential energy. So lower potential energy is what's going to always, you should never say always, is going to dominate a system. Like something is always going to tend, I just said always again, it's going to tend to a lower potential energy, okay? If I let go of the pencil, it's going to fall. That's lower potential energy. And when you have particles that are attracted to each other, the closer those 2 particles are, the lower the potential energy. So closer these oppositely charged particles, so this would be like an electron and the nucleus, the closer they are to each other, the lower the potential energy. So a lot of people at some point in this thought process might say, oh, well then why don't all the electrons just get like sucked into the nucleus? Okay, because there are other electrons here that maybe this guy's really close to the nucleus. There's more to that answer, but maybe this guy's really close to the nucleus. And this one says, well, I want to be close to the nucleus too, because I'm attracted to it. But once it starts to get close, now these guys start repelling each other. So there's this kind of like balance point between all of these different positive and negative particles in the universe, between like charges repelling each other, so negatives and negatives or positives and positives, and opposite charges attracting towards each other. And they have to all balance out to wherever the lowest potential energy is. And that literally is all of chemistry. If we could sum it up in one slide, one statement, it's that all of the positive and negatives are trying to achieve the lowest potential energy by being close to each other as much as possible, if they're oppositely charged, and pushing away from other things that are the same charge as them. Okay, so we'll keep coming back to this idea throughout the semester. All right, so now we're going to switch to mathy stuff. And I will preface this by telling you guys that all of the actual plug it in your calculator things that we're going to do today, you probably would not need to actually write out the work, but I need you to write out the work at least for this unit so that I can prove to you that you're going to need to continue to write out the work, okay? So we're going to do really simple conversions like centimeters to inches, whereas most people would just pop it in their calculator and be like, oh, this is the answer. I am going to teach you a very standardized approach. It's called dimensional analysis, where we look at the units and we set up a problem based on converting from one unit to another. And I want you to follow along and actually show your work. If we were in 7th grade, we would, I would collect it and I would make sure you showed your work, but you're grown up, so you just need to do it. Okay? So that's what we're going to do today. It's going to spend it's going to be a little painful if you are this is so easy. But just remember, it's not easy for everybody. So I'm going to try to balance that and go at a pace that, make sure that we have a thorough understanding before we move on. Okay, so the first thing to talk about is the fact that we're going to use the metric system because it's better, and we're stupid that we never switched over. Too bad. We're all thinking in terms of height. Like I said, my height, I was saying earlier that my daughter is 5 feet now, and it freaks me out because I'm only 5'2". So I think about it in terms of feet and inches, right? I don't think about my height in terms of meters. Most of you guys probably do as well. We need to be able to convert into things that we're used to thinking of, like inches and feet, into meters. So these are the standard metric units for length and mass, and we don't have volume on there, but like the standard metric unit for volume is liters. Okay, and we're going to convert things into that, and then we're also going to convert between metric units like that have prefixes. So in this example, this is because this is standard units. Technically the kilogram is the standard unit, but it's not the what I call the base unit. So if you have a prefix like kilo, that is not the base unit. The base unit for mass would be grams. Meters if you're talking about length, liters if you're talking about volume. But then we can also add prefixes. We could talk about kilometers or kilograms or kiloliters. We could also go smaller and talk about microliters or micrograms or milli or centa. All of those are metric prefixes that mean a particular thing. So that's the other thing that we'll cover today is like what you need to know of those, what needs to be memorized versus what you're going to be given, and then how to actually do the conversions. Okay? All right. So the first thing is I want you to pull up your exam equation sheet. So the 4-page document that you'll get on every single exam right here. So again, you don't have to bring this to exams. You won't be allowed to bring it to exams. I will just give you like a fresh copy at the back of every exam. But this is the information you'll have. So when you're doing practice problems or you're studying for the test and you're like, do we have to know blah, 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 blah? I'm going to say, well, if you think you need to know it and it's not on here, then yes, you're going to have it memorized. But there is a ton of information on here that people will memorize when they don't need to. Okay? So be sure to look at this and know, will someone in the back get the door for me? Thank you. If you think you need to memorize it, like double check and make sure it's not on here so that you're not wasting brain space memorizing something that's already given for you. Okay? All right. So one of the things that's given for you is that I will always give you some form of metric to English conversions. I don't make you know that. So like in this example here, I'm going to give you a length conversion. Let's pretend that you're given something in feet. Like I just said, what if I want to know my height in meters? Well, I'm not necessarily going to give you feet to meters, but I'll give you another English to metric conversion, centimeters to inches. And then you would know how many centimeters are in a meter. You would also know how many feet are in an inch. And so you could do the other parts of that conversion, but you'll have at least one English to metric conversion to make you switch between the two forms. If you're not from the U.S. and you're like, I don't know that there's, I mean, I'm sure you know there's 12 feet or 12 inches in a foot. But if it's something like that, feel free to ask. Like, oh, I know one that's like, okay, that's fluid ounces. But probably a lot of Americans don't know that either. Anyway, there may be some English to English ones that you might not be familiar with. Just ask me. I'll tell you those ones. But things like 12 inches in a foot is what I'm talking about. Okay? All right. So back to this one. So we're going to show you this basic approach. If you have one of these conversion factors, so the same one I just circled there is right here. 1 inch is 2.54 centimeters. And this slide is going to tell you how we go through a conversion like this. So the question in this case would be convert 2.81 centimeters to inches, or how many inches are equivalent to 6.81 centimeters. Okay? So the first thing is we're always going to set up problems by writing the number and the unit that we're starting with. I know that like you probably had that drilled into you in high school and middle school and stuff of like making sure you write units down. It's not just important in this kind of stuff, it's essential because the whole problem is based on moving units around. So the unit is just as important as the number, okay? So 6.81 centimeters, we're going to write that down. And then we're gonna use some conversion factor. And by conversion factor, I mean a number with a unit over a number with a different unit that's going to allow me to get to the new thing that I'm trying to get to. So the question said, convert 6.81 centimeters to inches. So I would start my problem by writing down 6.81 centimeters equals inches. So it's like a guide to tell me, so I'm just gonna write it so you see what I'm saying. 6.81 centimeters times some conversion factor equals inches. So that's how I would start the problem, is I would like leave a space for a conversion factor, and then I would write down equals the unit I'm trying to get to, so that it reminds me that that's where I'm heading, is towards inches. Okay? The goal here is to convert from centimeters to inches. And so the way that we do that is by canceling out the centimeters unit and getting the inches unit. So the way we do that is by whatever unit is up here, that's gonna have to go on the bottom. So this is just like if you had a number, like a 2 and a 2, if one was on top and one was on bottom, you could cancel them out. So it works the same way with units. So if you have centimeters over there, you put centimeters on the bottom. Okay? And then the unit that you're trying to get to goes on the top. So if I was doing this problem from scratch, I would write centimeters on the bottom, and I would write inches on the top, because that's the thing I know I'm trying to get to. And then I would ask myself, do I know a conversion factor that gets me from centimeters to inches? And by conversion factor, I mean like this equals that. So if we have 1 inch equals 2.54 centimeters, we can turn that into a conversion factor by putting one on top of the other. And we can switch them around, so we can have inches on top and centimeters on bottom, or vice versa, depending on how we need to use it. You just need to make sure that the number goes with the unit. So if it's 1 inch equals 2.54 centimeters, make sure that the 1 is with the inches. And if you flip it so that inches on bottom, then the 1 needs to be with the inches, the 2.54 is with the centimeters. Okay? So if I'm doing my problem and I've put centimeters on bottom and inches on top, and I have these 3 questions like on 1 or 2 slides forward where it says like, what is the thing I'm starting with? Centimeters. What's the thing I'm trying to get to? Inches. Do I know a conversion factor that gets me from centimeters to inches? Okay? So I have those written down further if you want to refer back to them. So I go ahead and put the correct numbers in. 1 inch is equivalent to 2.54 centimeters. And now that's the math that I have to solve. So I'm using the units to set up a problem. So this is a very different way, and this is literally the rest, 90% of the problems we do in chemistry, like math problems, will look like this. It's a very different way than like a physics class where you have an equation, and we'll have some of those, but again, that's like 10% of them, where there's an equation and you plug numbers in. It is much more going to be you kind of developing the pathway to get to the right answer. And that throws people a lot of the time. They'll get studying for the first test and they're like, I just don't know which like equation, I don't know how to set up the equation. This is what I mean when I say, or this is what you should think when you say, I don't know how to set up the equation. It's not an equation, it's a process. So you start with the thing you're starting with, you find a conversion factor that gets you to the thing you're trying to get to. Okay, they'll obviously be a lot more complicated than this. We'll get to the point where you've got like 3 of these conversion factors that get us from the number to the thing we're trying to get to. Okay, so how do you punch this in your calculator? This is like the 1 or 2, this is the day that I'll actually show you how to do these. Okay, I take that back. There will be other times when we start getting to 10 to the 23rd, I'm sure I'll show it to you. Okay, a note on that. I put on Blackboard, I just listed under the files, like the calculator that I would recommend. So you cannot use your phone on the exam. You cannot use your phone on the exam, okay? I usually try to remember to throw a couple extra calculators from my house in my bag on an exam day, just in case. But if you show up to campus and you don't have a calculator, go run around and find one. Like, go to the department office in math or science or something and be like, is there an extra calculator I can borrow? Because you need to have a calculator and you cannot use your phone, okay? I cannot say that enough. So the one that I recommend is $10 on Amazon. It's like the TI 30X, I think. Really basic scientific calculator. And what I would recommend is that you start using that now. Don't like just start, obviously I'm going to use my phone or my iPad because I don't have to take a test. But you want to use the calculator you're going to be using on the exam as you're working through it, because you want to make sure that you know how to use it and that you know what it looks like and where all the buttons are. Okay, so get yourself, you can use whatever, as long as it's a scientific calculator, just start using that now and you can grab that $10 one if you don't think you have one that works, okay? Okay, so what was the number? 6.81? Yes. All right, 6.81. And then it said times 1 over 2.54. So you could write that as like times 1 over 2.54, and you'd have to put parentheses in there, okay? You can do that. Well, you don't have to in this instance put parentheses, but obviously since that's a 1, you can just say 6.81 divided by 2.54. Okay, those would be equivalent to each other. So it's 2.68. So numbers on the top times numbers on the top divided by the number on the bottom. Okay, so 2.68 inches. Okay, so this is an English to metric or vice versa, metric to English. We're also going to have to go between metric conversions, okay? I do it a little differently, and I will try not to slip back into the way that I prefer. I'm going to try to stick to how the textbook does it so that there's consistency. So this is the chart from the textbook, and you are going to have to know the multiplier that corresponds to the prefixes that have stars next to them. So what do you have to have memorized? You have to have those prefixes. Like if I say kilo, you need to know that the multiplier is 10 to the third. Okay, this one, or 1,000. If I say centa, you're going to have to know that that's 0.01 or 10 to the negative second. I would not try to memorize it as like 0.000, just memorize the multiplier, and I'm going to show you, like remind you what scientific notation looks like. I'll spend a little smidge of time today telling you, reminding you about scientific notation. If you're not comfortable with it, you should go back. I think there's actually like I don't remember what they call it, but it's like an optional math tutorial in Pearson. So it should be listed in your assignments, and I think it says optional in parentheses. I'll go double check that after this, but you can use that if you want like a quick refresher on scientific notation, okay? All right, so let's say that we want to convert, so let me just give us like a simple problem. Convert 100 liters to centiliters, because that's one that like nobody talks in centiliters. So let's do something that's unfamiliar, okay? All right, so we're going to have the same general approach. We're going to start with the number in the unit. Let me make this a little smaller so we can put it all in there. Okay, ignore this for now. So 100 liters, and I'm trying to get to centiliters. So you need to know that the prefix for centa is just a small c. And you are going to have memorized that the multiplier is 10 to the negative second. We're going to show you what that means and how to use it. So just like the other problem, I'm going to put liters on the bottom because that's the thing I want to get rid of. And I'm going to put centiliters on top because that's the thing I'm trying to get to. And then I'm going to find what are the right numbers to put in those places. Okay, So the multipliers that you're gonna have memorized, and these are actually pretty easy. Centa's the only one that's not a multiple of 3 that I have you memorize. So like milli, micro, nano, pico, those are 3, 6, 9, 12. So like as long as you remember that they come in threes and like what order they come in, it's gonna be relatively easy to remember. These guys are negative, and what that means is that the decimal point moves to the left. So if I say 1 times 10 to the negative, well, let's just do the second since we're doing that. 10 to the negative second is the same thing as if we were writing it in scientific notation, we would say 1 times 10 to the negative second. The negative means we go to the left, or we make it less than 1, and we go by 2 places. So like the decimal point is here, so we go over 1, over 2, and that's why it's equivalent to 0.01. So that's what I mean when I say 10 to the negative second. Just like if I say 10 to the negative 6th, I took the decimal point and I moved it over 1, 2, 3, 4, 5, 6 places. So 10 to the negative 6 is equivalent to 0.0000, did I say 5 zeros? 1. If it's positive, you're moving it to the right. So it's like you take 1 and then you go over 1, 2, 3 spaces. So 10 to the third is equivalent to 1,000. That's how scientific notation works. So when we get an answer, I should have used something that wasn't 100, but if I write, 6.9 times 10 to the 4th, that is equivalent to moving the decimal point 4 places to the right, or 6.9001234. Okay, so the decimal was here, and I went 1, 2, 3, 4, and now the decimal point's there. So those two numbers are equivalent. That's your tutorial for scientific notation. If that's not enough of a reminder, go do the one on Pearson or in your textbook. Okay? All right. So when I look at centiliters, back to our problem, when I look at centiliters and it says that the prefix is 10 to the negative second, that means that 1 liter or gram or meter, whatever base unit you're talking about, one of those things, I said that the wrong way around. One of the prefixed thing, 1 centiliter, so I'm going to put a 1 here, is equivalent to that many, the prefix of the base unit. So 1 centiliter is equivalent to 10 to the negative second liters. So the prefix, sorry, not the prefix, the multiplier is tied to the base unit, and then there's 1 of the other thing. So 1 centiliter is equivalent to 10 to the negative second liters. So I have a couple examples written here. But did I do these the way the textbook does? No, ignore these ones. Or ignore some of them. We'll see which one can we pay attention to. No, that one works. No, they actually both are good. So the 1 is associated with the thing that has the prefix 1 kilometer or 1 centimeter. And then the prefix is tied to the base unit. So 1 centimeter is 10 to the negative second meters, or 1 kilometer is 10 to the third meters, because that's the prefix for kilo, 10 to the third. Okay, so now I have my conversion. Now I need to just do the math, which would be 100 times 1 divided by 10 to the negative second. So I'm not going to do the times 1 part. So I'll show you quickly in the calculator again. 100 divided by, and instead of writing 0.01, I'm going to show you where the button is on my calculator at least, so that when you're doing something that's bigger than 10 to the negative second, maybe it's like, 10 to the negative 21st, or positive 21st for that matter. So most scientific calculators are going to have a log button, log base 10. It might not say 10, it just says LOG. And then above that key is where the 10 raised to the number is going to be. Okay, so 100 divided by 10 raised to the negative second. What was my problem again? Oh, liters. Okay, good. I was like, that doesn't look right. Okay, so 100 liters is equivalent to 10,000 centiliters. If you know how to do that math in your head, great. If you're going to plug it in your calculator, make sure you're doing it correctly. Another note about scientific notation, if you are using like a number like 6.9 times 10 to the negative second, I would put the whole thing in parentheses just to make sure that you don't mess up the order of operations. We'll get to that when we see examples of it later on. Okay. So that one would be 10,000 centiliters. All right, so do one of these on your own slash, you can talk to your neighbor or whatever. But do it my way. Write the number and the unit. A conversion factor equals the unit you're trying to get to. Okay, so we're converting 294.5 nanometers to meters. When I say using dimensional analysis, I mean do it my way. Show your work, do a unit conversion. And I will go ahead and send around the roll now. There's 3 pages, so try to keep them together. I don't have a stapler. Check by your name. Just put a check mark over here. And if your name is not on here, come talk to me at the end of class. Thanks. Okay, so your setup should look like this to start. Number with its unit times some conversion factor equals blank meters. Then nanometers needs to go on the bottom because that's the thing we're trying to get rid of. Meters needs to go on the top. And then remember, it's always one of the thing that's not the base unit. And then you need to remember what the prefix nano, what the multiplier is for that, which is 10 to the negative 9th. So that goes with the base unit. You guys know what I mean when I say base unit? Like just grams or just meters, no prefix associated with it. And then that's your problem. So then you type that in your calculator, or you just, do the math in your head, which if you can, that's great. And that's 2.945 times 10 to the negative 7th meters. I never seem to leave myself enough room to write the number. And that's how metric conversions work. The number stays the same and the decimal point just moves. That's why it's far superior. Especially before there were calculators. My dad's old enough that he like used a slide rule in college. I was like, no, I should watch a YouTube video on how you even use that. But scientific notation, that was a big part of it, was it was difficult to deal with large numbers, and small numbers, really small numbers, when you didn't have a calculator. Okay. You're going to have to do lots of these. You're going to have those multipliers memorized. Don't be surprised. I'm not going to go through it in detail after this. All right, let's do another one that requires 2 conversion factors. Okay. Now, I'm going to let you guys take a few minutes to try this on your own. You can either do this as like 2 different parts of the problem, or you can do it as 2 conversion factors in one single problem. So I'm going to show you both ways, but you kind of just decide what you want to do. I want you to think about these questions as you're working through it. So what is the unit that I'm starting with? You're going to need to write down the number and the unit. What's the unit of the thing you're trying to get to? And then what conversion factors do you have to use to get you from one to the other? We can plan out calculations using what we call a unit route. And maybe I'll do that in this problem since we haven't done one with 2 yet. And then I'll let you guys do it. So what is the unit we're starting with? We're starting with milliliters. What's the unit we're trying to get to? So I skim through the question. I have one number and one unit, and then I'm looking for another unit, blah, 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 quarts. Okay, so don't make this more complicated than it needs to be. Sometimes people get so freaked out when they have a word problem, right? Like, there are literally just a few key points. Number and a unit, another unit. Okay, those are the only important things. I could just like not even pay attention to the rest of the question at this point. Okay, so the unit I'm trying to get to is quarts. And then I can ask myself, do I know a unit or a conversion factor that gets me from milliliters to quarts? Well, that is an English to metric. And it says I'm going to have to use conversion factors from the previous slide. So like, let's just scroll up and see. You could look at your exam equation sheet, or I can look at this one here. For an English to metric that somehow involves volume, hopefully quarts. Okay, there's gallons and liters, which yes, there are 4 quarts in a gallon, so I guess I could use that one if I wanted, but I also have liters and quarts right there. So that's good. I can get from liters to quarts, but the question didn't give me liters, it gave me milliliters, right? But what's nice about metrics is they're very easy conversions. So what I'm going to do is I'm going to go from milliliters to liters, because this is a simple metric conversion. And then I'm going to use that one that was in the table to go from liters to quarts, which I believe was 1.057 quarts per 1 liter. I better verify that so I didn't mix them up. Yes. Okay, so the blue part, that's a unit route. It's like saying I'm going to start with liters, I'm going to go to, or start with milliliters, I'm going to go to liters, then I'm going to go to quarts. Me adding in the red was just like reminding myself how I'm going to get from one to the other. Okay, so go ahead and write out the work. Don't just do the problem. I don't care if you get the right answer if you don't show me the work. So go ahead and write out the work, and you can do this as like one problem, find the answer, do the second part and find the answer, or if you feel comfortable with it, you could do it all as one with just 2 different conversion factors. Okay, talk to your neighbors if you're want to check answers or work through it together. Where's the roll at? Did it make its way around yet? It's making its way around. Who has it? Who has the roll? Did somebody eat it? Why is nobody fessing up? Is it around? I feel like yes, maybe it is. We'll see. I think someone ate it. Okay. We have 2 dogs, and one of them, she eats everything. Like, we found this toy horse, like a hard plastic horse. Its head was gone. My son has a rubber duck cemetery for all the ducks who Penny has eaten the heads off of. So I will start the problem up here. I won't do the whole thing, but I like to kind of start the work so that if you're stuck, if your neighbors are stuck, that you can kind of get started. Okay, so I have the general setup. I'm going to go ahead and put the numbers in for the conversion factors. I'll do those in red. So okay, so once you get to the point where you're using multiple conversion factors, a unit route can be really useful, and you can think about it as 2 separate steps in this instance. So we go ahead and convert from milliliters to liters and get 0.559 liters, and then we can carry that number to the next part of the problem. And the quarts would come out to be 0.591 quarts. We'll talk about on Wednesday, we don't have class on Monday, don't forget. But we'll talk about why I wrote 0.591 and not 0.59 or 0.5909 or whatever. We'll talk about that on Wednesday. Okay, so there's nothing wrong with doing them as 2 separate problems. You can do them as one. And if you feel like this is just going to be confusing for you, or you get into it and you see me doing them as multiple steps together, then just stick to doing them separate. It's just a little bit more writing. And sometimes if you carry, like, let's say you cut off this number. In this one, there's no cutting off because it's only 3 digits anyways. But like if it was a number that continued on and you cut it off and then moved it down to the next one with not enough digits, why are you guys all packing up? There's still 5 minutes. Put your notebooks back. All right. If you take this number and for some reason you cut off some digits when you move it down, you can get a rounding error. So that's one reason why we like to do them all together as well. So on the bottom there, I wrote it the way you would do it if you were doing them all together. So it's like this first step is what gets you to leaders. And how do I know it's getting me to leaders? Because that's what's on the top. So if I stopped right there, I would be in leaders. But then I just go ahead and add the second conversion that's going to get me from liters to quarts. And then I can do the problem as one long thing. So when I punched in my calculator, I just say 559 times 10 to the negative third times 1.057. And then it's just in one step. Okay? And you'll get the same answer, obviously. Okay. So I'm not going to do temperature. I'm going to have on your own because it is just equations. So there are these two equations. They're on your exam equation sheet. So if you hit some of these as you're starting on the dynamic study module, just do them because it's really fairly straightforward. I'll do examples once we get to using them in a problem. Okay? And then maybe I'll just introduce this problem and we'll kind of pick up there when we come back. But when we have conversion factors that incorporate squares for area or cubes for volume, you can use the same conversion factors that you have from before and just square the conversion factor. So in this example, it's talking about centimeters and meters. So we know that the prefix for centa is 10 to the negative second. So the conversion factor that we would start with here is 1 centimeter is 10 to the negative second meters. But that's not what the question is asking about. The question is asking about centimeters squared and meters squared. And we don't have like a separate conversion factor for that. What we need to do is square the conversion factor. Okay, so if you run across any of these in the homework and you want to start trying them, that's the approach you need to take, is find the conversion factor and then square it if you need to have squared, or cube it if you need to have cubed. Okay, so I'll leave that there and we'll just do this as like an intro problem when we come back on Wednesday. Okay? I still let you guys out 3 minutes early, just so you know. Kenzie is not here. No Kenzie Gibson. Oh, poor Kenzie. I think I emailed her and she didn't
Really, question?
write back. Yes.
So look, when I was doing it in my calculator, I don't know if I'm when I did the log, I don't know if I'm in the right place. Like, let's say if I did 294.5, and you said you don't times it, so you just divide it by.
So that would be times 10 to the negative second. You don't have to divide by the 1. Times, and then you're going to need to use...
Do I hit 10? I mean, do I have 10?
Yes. I'm trying to see if there's a... No. Okay, so you can either do 10 raised to the negative second.
Okay, that's what I was trying to do.
Or, I actually think it would be better... If I hit clear, is it going to erase the whole thing?
Yeah.
Okay, can I just like... There we go. Okay, if you want to use the log button, it's actually the one that's above log in blue. So you hit second, that, and it does 10 raised to that, and then you just do negative 10. So that's the same thing. It's the, yeah.
All right, thanks.
Oh, wait, 2.94.
2.9.
Oh, I said negative second. It's supposed to be negative ninth. I don't know why I did that. So 294.5 times 10 to the negative ninth. Okay, So now it's not putting it in scientific notation for you. Trying to see if there's a button on here that will do it for you. So if you move the decimal over, you'll see that it's 2.95 times 10 to the negative second. There's probably, let's see if we do that. Will it go? Ha, yeah. So I told it to go to scientific notation, so second and scientific, and now it says 2.945 times 10 to the negative 7.
Okay.
So that little times 10 to the negative 7, that's putting it in scientific notation for you.
All right, thank you.
Yep, that's actually the one that I recommend people buy, so now it's good, in case other people come in with it, I'll know how to answer it. Hi.
Did you do this? Because when I was on the episode, it kept saying,
It kept saying what? It could be a pop-up blocker. Did you email me about it? Oh, you did? Oh, and then I responded and said, is that the one where I said, show me a screenshot, or, okay. Yeah, you can bring it up there. Why don't you pull it up and I'll, let me just blank this out so that I'm not getting blinded. There we go.
If I'm doing the finger scratches like this,
Yes, so that's
that
how I
fine?
like to do it.
because
So
that's
this
how
is
I learned
100.
how to
Yes.
do it, and
Yeah.
I don't know if I should be
No,
switching to how
no,
you're doing it.
it's fine. In fact, I prefer, do you mean because you're doing this and then that instead of squaring it? Or do you mean because you're doing 10 to the second centimeters per 1 meter?
Both.
Both, okay. Both of them are fine, and I prefer this way, because then there's like a lot of little things in a big thing.
That's how I
Instead of- yes,
think about it.
that's
Because
fine.
instead of it being like
A
one really
fraction of a
tiny thing in a one small
Yeah,
thing. Like,
yeah. No, it's fine.
Okay.
And that's where I kept having to like check myself, because I prefer that way, but the textbook doesn't do it that way. So you're totally fine. As long as
Okay.
you know what you're doing, you're good.
Thank you.
Yeah. Yeah, so go ahead and hit, sorry, yeah, just hit open. Oh, okay, yeah, then you're good. Yeah, that's your pop-up blocker. I can tell right away. So if you click up here, try hitting refresh and let's see if it says pop-ups blocked. Yeah, so now click on that. Oh, okay, I don't know why this keeps happening. Let me try it and see if I can do it fast. If I hit refresh, pop-up window blocked. Okay, so how do I say unblock it then? I would almost just, do you know where the tech office is on the second floor? Yeah, so I would almost just go ask them if you're not sure, but there's gotta be a way for you to tell your computer, like, well, stop blocking them, because it's telling us it's blocking them, we just don't know where they're going to.
See, this is what I was used to.
Yeah,
This is how I
that's
got
fine.
it.
Yeah, that works. So you've already done the oh, I remember which email was now. Yeah, so you did the chapter 1 reading, and then this is the one that I've been talking about, like when you're doing the homework, the little squiggly line ones, you can, right, so you can start on that one. It's not due for another week, but that's the one you want to start on now.
Yesterday.
Yeah. Yep.
Do you have it Thursdays? Weird that like